equation of projectile motion. So let's just give summary of the equations of motion. So summary of equations now. Summaries of equations of motion. So let me state them out. So I will use my f of x to do the input. So let me use f of x equation, which is saying this. Alright, so the first equation I have v equals to u plus at. So this is my first. Let me just put it here. Let's say 1st. So this is my first. Okay, so let's go. So let's go to the second. So the second one is s equals to ut plus 1 over 2 at squared. So let's give some space here. Okay, so this is the second. Then the third one is, going to be v square equals to u square plus 2ax. So these are the three equations of motion. Let me take it to MS Word. So you can see the three equations of motion. So with these same three equations of motion, I can derive a projectile motion. So how do I do that? Let me first of all demonstrate how a projectile motion looks like. Let me use this applet to do the description. So in projectile, take note, we are not just moving on horizontal ground or on a vertical level. So what we are doing is we are moving at an angle. So you can see this object is being set at an angle of 50 degrees to the horizontal, and the initial velocity is 25 meters per second. So this is the initial velocity I will use to project. So if I come here and project, the angle of inclination is already 50. The initial velocity is 25. So if I project, just watch how the object will move on the sky. So you can see how it moves from 0, it's moved down to around 62, 63, somewhere here. So let me go back gently so that you watch the path, how it moves. So you see the path of the motion, how it moves. You see how it goes till it will get to 0. So you see, so when you project it, it will move initially at an angle of 50. Then when you get to a particular height, you see as it's going gradually, when you get to a particular height, it will start to form a curve. So you can see the parabola curve that is forming. So at a particular point somewhere here, it will attain its maximum height. So you can see it. Then it will continue to fall again. It's dropping down until it hits the level on the horizontal ground. So from this point 0 down to around 62, 63, which is given as 62.81. So you can see. So this is the range. Then the time it got to this maximum height is the time to achieve maximum height. Then the time it used to move from this 0 down to this place is called the time of flight. Then sometimes you may be asked to calculate the maximum height. So what is this maximum height attained by this projectile object, this object that is being projected? So what is the maximum height that is somewhere it attained before it starts falling down to the ground? So all these formulas, you should know how to derive them. Good science student or as a teacher of physics, if you want to teach your children, so that if you forget it, you should know how to use it. So let me start the derivation now using these three equations of motion. So we are going to use this equation of motion to do the derivation. So to start, there's one thing I want us to take note of now. So you know this is projectile. So projectile works with gravity because the object is thrown up. So the object is worked upon gravity. So it's acted upon by gravitational force, and we have a constant for gravity on Earth, which is the 10 meters per second square, and we use small letter g as the symbol. So to start that, take note, these three equations, there are some things I need to change. Let me edit. So if I, okay, let me not edit directly. Let me copy this first. I'll paste it somewhere here. Okay, so it is this one I will edit. So I need to edit some things here. So let's go. So now for projectile, this A, which is acceleration, will become G. So it will become gravity. Take note of that. Then S in this case will become H. So it's no more distance, it's now called height. Take note of that. Then the same thing here, G, A will become G. So all these are some things you must take note of. T still remains time. V and U remains final velocity and initial velocity. Then the same thing here, A will turn to G, then S will turn to H. So take note of this. So these are the changes we need in this formula. Then another thing you must not forget, for projectile, let me go back to MS Word. For projectile, when the object is going up, remember this projectile, the object is moving from ground to the top. So all these three equations, this positive value will become negative because in projectile motion, they are all acting against gravity. So if I want to derive my equations for projectile, this positive, I'm going to make them negative. So take note of that. So to start the derivation now, all these three equations, plus, 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 I'll turn them to negative. So let's start now. Okay, so let me start with the first one. The first one I want to derive is time to reach maximum height. That formula is very important. So let's start with time to reach maximum height. So let me start with this. Let me highlight it or bold it. Okay. So time to reach maximum height. I know what this one means. That is when this object was at zero, something like this. When you start projecting it, see, so the time is counting. So when you attain the maximum height somewhere like this, so this is the maximum height. So what is the time you used to achieve this maximum height? How do we calculate this time? So to do that, I need my first equation. So time to reach maximum height, I'll use my first equation. But take note, there's one important thing you need to take note before we start. In projectile, this object is moving in two directions. You see, as it move at an angle like this, 50 degrees or whatever degrees is being moved, whatever degrees, I can change the angles here. So whatever angle is being moved now is moving in two directions. We have the vertical direction. Let me get my pen so that will demonstrate it. So it's moving in two directions. So this is vertical direction. You can see it is going up and it's moving in another direction. This is horizontal direction. So now because of that, this velocity now is being resolved into two axes. So we have the y-axis, which is the vertical axis. Then we have the horizontal axis here, which is the h horizontal. So how do I resolve it? So what will V turn to now? So this V, now this is the angle now. Don't forget this is 90 degrees. So this is a triangle now, a right angle triangle. So the hypotenuse is on this side. So this is the horizontal axis. So this is the vertical axis. So this vertical component of the velocity now, this 25, which is u. Remember, this velocity is initial velocity now. It's now equals to 25 meters per second square. So how do I get the initial velocity of this one? And don't forget this 50 is angle theta. Very important. So this angle theta 50 degrees. So this is the velocity, initial velocity, which is u. So how do I get the velocity for the vertical component? This is basic math. Just do your opposite over hypotenuse, and that is going to be sine opposite over hypotenuse, which is going to give us u. This is u sine, going to give us u sine the angle on that plate, and the angle we usually use theta as the angle. So our vertical component is v sine theta. Then the horizontal component h is going to be what now? So this is adjacent side, which is adjacent over hypotenuse. So this is going to be cos. So this is going to be u cos theta. So remember that. So these two components are very important before we start our derivation of the equations. So horizontal component is u cos theta, vertical component is u sine theta. So that is what I'll start with first. So take note of that. Let me hide my formula. So take note of the derivation, take note of that. So very, very important. So that is what I will start with before I start my proof. So time to reach maximum height. Before I will start, I need to state my vertical component velocity. All I need to do is to write vertical component velocity. Let me remove the boldness. Vertical velocity. Vertical velocity will be what? Let me use this. So it's going to be u sine theta. So u sine theta, let me give some space after the u. So this is vertical component velocity. So let's go to horizontal now. So horizontal velocity will be what now? So how do you get your horizontal velocity? I've demonstrated it. So let me type it here. So horizontal velocity is going to be u cos theta. So that is horizontal velocity. So take note of that. So these are the two important velocity you need. So the two velocities I will use now to replace my v and u when it's time to get the formulas, it is either it acts on vertical velocity or horizontal velocity. All right, let's move on. So time to reach maximum height. How do I get it? So I'll use this formula now. So which is v is equals to u plus a t. Now remember the principle now. At maximum height here, v is going to be 0. So at this point, v is going to be 0. Let me bring out my equation. Let me delete all this one. Let me erase them. Let me erase all this first. Okay. All right. So at this point, at maximum height, v is equals to 0. Then u is 25. So this is u. So u is equals to the initial velocity. So initial velocity have value. So final velocity is 0. So don't forget that. So to start the first equation, all I need to do here is to bring this formula out. So let me go to my fx now to do it. So I have my v equals to u plus gt. Now remember, because this is going up, because it's going up, don't forget, because it's rising up, so this plus is going to be negative. So it's going to be v equals to u minus gt. So we are going to use negative value. Let me give some space. Okay, now v is going to be 0. So v is going to be 0 equals to u. And remember, this is a vertical motion, so it's going to be u sine theta. Let me give space after the sign. It's going to be u sine theta minus gt. Now make your t the subject of your formula, which will now become gt equals to u sine theta. Now divide both side by g. We are going to have t equals to u sine theta divided by g. Okay, let me correct this. I need to put it in bracket before I can divide it well. Yes, so that is it. So this is the time to reach maximum height. So we have proved this one very easy and direct. So remember, time for a projectile to reach maximum height is u sine theta all over g. So the v is going to be 0 because at maximum height v is 0. Then the velocity we are using in this case is a vertical velocity, because for the object to rise up, it's going to rise up with particular velocity, which is a vertical velocity, but you are looking for time to get to the maximum height. So take note of this. So that is that. So with this formula, I can prove my other formulas now, which is my range, my time of flight, and the rest. So let's go. So let me first of all get my time of flight. So how do I get time of flight? So how do I get time of flight? Let me bold this. Now, what is time of flight? Time of flight is the time for the object to move. Let's go to the projectile now. So time of flight is the time for this object now to move from this down to the maximum height, then from the maximum height down to the ground, something like this. So time of flight is when this object starts, it flew like this to the maximum height and continue and hit the ground. So this is time of flight. So what time will this object move from down, get to the highest, and drop to the ground? So to get this time of flight is easy. Just multiply time to reach maximum height by 2. If you multiply time to reach maximum height by 2, you will get your time of flight. So time of flight is now time of flight. Okay, let me use capital T as my time of flight. Let's use capital letter T. So capital T is now going to be equals to time to reach up by time to reach maximum. Time to reach maximum height multiply by 2. So times 2 by time to reach maximum height. So just multiply this formula by 2. This one will just give us a capital T equals to, okay, let me type it in FX. So time of flight is going to be capital letter T equals to 2 u sine theta. Let's also put it in bracket, 2u sine theta divided by g. So this is the formula for time of flight. It's very easy. So I've proved it. So the first formula you need in projectile to get all the formulas is this time to reach maximum height. If you can get this, all other formulas will be easy for you. All you just need to do, time to reach maximum height, which is this, multiply it by 2, you get your time of flight. So this is time of flight formula, very easy. Now that you know your time of flight, how do we get our range? Let's get range. So range now, let me highlight it and bold it. So range, which is the same thing as, let me use capital R to represent my range. So range will be what now? So R is going to be horizontal velocity, horizontal. Remember the horizontal velocity I derived the other time. Horizontal velocity multiply by time of flight. So this is the formula for range, horizontal velocity times time of flight. So if you scroll up now, so you can see this horizontal velocity, u cos theta, multiply it by this your time of flight you just derived now. So that will give us what? Let me go to a new page in MS Word. Okay, so that will move us to, okay, let me type it in FX equation. So we said capital R equals to horizontal velocity. Remember we say u cos theta, then multiply by time of flight. We say 2u sine theta divided by, let me put the bracket here, divided by g. So this is the formula now. Now if I simplify this further, I'm going to have my capital R equals to u. Let's multiply now. You know I'll multiply this u times this other u, which is going to give me u square, then let me put, I want to separate these two sine theta cos theta on one separate side. That's u square times 2, that is 2 sine theta, then cos theta. And this is what I want to do. Then divided by g. Yes, so this is it. So now in a trigonometric identity, this part, that's but this part of it now, which is 2 sine theta cos theta, this part, sorry, this is 2. Let's give enough space. But this in trig identity is equals to 2, sorry, is equals to sine 2 theta. So this part of it is equal to sine 2 theta, which is this. So therefore, our range, which is capital R, will now be equals to what? So range will now going to be u square. So u square sine 2 theta. So this is the range now. Then don't forget, divide it by, let's divide it by g. So this is our range formula. So range is going to be u square sine 2 theta over g. So this is our range. So take note of this. Range is u square sine 2 theta all over g. So we have derived range. Then there are other conditions, like when range is maximum, the angle is going to be 9 and 45 degrees. So all those, you can easily do that as you are doing your calculation. So let's leave that one for now. So but for range is u square sine 2 theta all over g. Let me just put it as a statement. The maximum now, maximum range. So maximum range is when theta is when, let me type it here. Maximum range is when theta is equals to 45 degrees. So this is the condition for maximum range. So if you want to get range maximum, all you need to do here, okay, let me type, if I put theta to be 45 now, which will become sine 90, and sine 90 is 1. So in that case now, remember 2 times 45 now will give us 90, and 90 is going to be 1. So maximum range, let me type it here. So maximum range will now be R. Let me make it something like this. Sorry. Something like this. Range maximum is going to be equals to u square divided by g. So this is maximum range. So take note of that. So range is maximum when theta is equals to 45. So 2 times 45 is 90. Sine 90 will give us 1. So therefore maximum range is sine u square all over g. So that is that. So now that we have known our range, the last equation we need to learn now, how to get our maximum height. How do you get your maximum height? Alright, so to get maximum height, I'm going to use this equation, which is the third equation of motion. So h in this formula is height. So that is maximum height. So how do I get my h? So let's write it here now. So maximum height. Let me use capital H to represent that. Let me bold it. So how do I get my maximum height? So I will use this equation of motion, the third equation of motion, which is v square equals to u square. Remember, maximum height is going to be negative because we are rising up, which is, don't forget, so we are talking about the highest point you can get to here. That is the maximum height, something like this. So this place like this. So this is your maximum height. Don't forget that. So this is the maximum height you can attain. So how do we calculate this? So to calculate this, I need to use the third equation of motion. Then because the object is rising up, don't forget V is going to be 0 at maximum height. So V is going to be 0, very important. Then U is already initial velocity, so you have that one. Then another important thing again in this case is G, the gravity now is going to be negative. So G is going to be negative value. It's going to be a negative value because it's acting against force of gravity. So with this knowledge now, let's go back to our work. So if I come back to my work here, so I have my v square equals to u square minus 2gh. Let's use capital H, 2gh. Then now don't forget v is 0, which is 0 square, which is or 0 raised to power 2, something like this, is equals to, let me give you space before that, is equals to u square then minus 2gh. Now don't forget this u, remember, is a vertical height, so we are not going to use this u. Let me put it in bracket. So we are going to use the u sine theta. So this is the u we are going to use, which is u sine theta. So with this, it will take us to the next line. Take your negative 2gh to the other side. This will become 2gh equals to, by the time you open this bracket, which is when you simplify this bracket, you are going to have your u square sine square theta. So this is what you are going to have. Now divide both sides by 2g. You are going to have capital H equals to u square sine square theta. Need to put it in bracket as well. Sine square theta divided by 2g. So this is maximum height in your projectile. So maximum height of a projectile is h equals to u square sine square theta all over g, all over 2g. So this is how you can derive the equations for projectile motion when you want to do your calculation. Maximum height is u square sine square theta over 2g. Range is u square sine 2 theta over g. And the maximum range is when theta is 45 degrees, that u square over g. Then time of flight is 2u sine theta all over g. Then to get your time to reach maximum height, it's going to be u sine theta over g. So just take note of how we derive these three basic equations in projectile motions, which is maximum height, range, and time of flight. So that is all I have for us in this video. But before I go, let me just put the three summaries now. Let me put it in a PowerPoint. I'll copy and put it there so that you just see the three formulas now of projectile motion, three basic formulas of projectile motion. So that is that before we go. All right, so this is the summary of the three basic equation in projectile motion. So to start, this is time to reach maximum height. So that is t is equals to u sine theta over g. Then this is the time of flight, which is 2u sine theta over g. So take note of that. Then this is the range, which is u square sine 2 theta all over g. Then if you need your maximum range, remember theta is going to be 45 degrees. So maximum range is u square over g. Then finally, your maximum height, which is u squared sine squared theta all over 2g. So these are the equation for projectile motion in our basic physics or in further mathematics in our curriculum. So that is all I have for this video. Thank you so much for watching this video. Do have a nice day.